Hello everyone, I welcome you all to my channel Revealing Concepts. In today's class, we would be starting with a new chapter, Polynomials. This is chapter 2 of class 10th NCERT. So what are we going to learn in today's class is we would start with what are the zeros of polynomial, and then we would see the relationship between the zeros of the polynomial and the coefficients for a quadratic polynomial as well as for a cubic polynomial. So let's start. First, we are going to see what does zeros of a polynomial mean. Now, we all know that what's a polynomial. A polynomial is, a mathematical expression which consists of variables and it consists of constants, and they are combined together using different mathematical or arithmetic operations. So, any, statement of the form 4x plus 2 or 2x square plus 8x plus 6 or 4x cube plus 2x plus x cube plus 6. So these expressions of these kinds are called as polynomials. Now why do I say them as expressions? Because there is no equal to 0. If anything of this kind is called as an equation or a polynomial equation, but this is just a polynomial expression, right? So statements of this kind where you have combinations of variables and constants or variables and coefficients or numbers with the usage of or combinations of various arithmetic operations like multiplication, addition, subtraction, and even division. Such combination is called as a polynomial. Now the topic for today, that is zeros of a polynomial. What do zeros of a polynomial mean? So the definition on the board says that some values, zeros are basically some values of variables. I hope you all know what are variables. The letters that we use in algebra are called as variables. So the some values of variables for which the polynomial will be 0. So the values for the variable in the polynomial such that when you put that numerical value in place of that variable, let's say if the variable is x, then the resultant value of the polynomial that you get is equal to 0. So such values which when substituted in place of the variables in a polynomial gives you the value 0 are called as the zeros of the polynomial. And we also know that they are also called as the roots of the polynomial. Right? So the zeros of the polynomial or the roots of the polynomial are those values for which, those values of the variables in the polynomial for which the polynomial becomes equal to 0. And when the polynomial becomes equal to 0, the resultant value that we get is also called as the solution to that equation. So whether you say zeros of the polynomial or you say the roots of the polynomial or the solutions to the equations, these are the three terms that are interchangeably used, and they are nothing but the values of the variables for which the polynomial comes out to be equal to 0. In your previous standard you have learned how to calculate them. We all know the very basic method of calculating the roots or the solution or the zeros of a polynomial using the factorization method. So using factorization method, what we have calculated is the roots of a quadratic equation. Now let's move on to part 2 of this class, that is knowing the relationship between the zeros and the coefficients of a polynomial. Now why did I mention this? Because it would be used over here. So now we are going to see there is some relation between the zeros and the coefficients of a quadratic polynomial and also a cubic polynomial. Now what do you mean by quadratic polynomial? Any polynomial whose highest degree of the variable is 2 is called as the quadratic polynomial. So now here we are specifically going to see the relationship between the zeros and the coefficients of a quadratic polynomial with highest degree of variable to be equal to 2. So here we have taken a polynomial. This is an example and we are going to derive the relation. So there is a polynomial that I have taken and the polynomial is 2x square plus 8x plus 6. Now here if you see, I have done or I have used the factorization method wherein I have splitted the middle term as -6x and -2x, because 6 and 2 are the factors for number 12, which is 6 into 2. The basic factorization method is known to all. So using the factorization method, which method? The factorization method, which is normally used to calculate the roots of a given expression or the solution to an expression, I got or we got the values of x to be 1 and x to be 3. So what these are basically the values for the variable, such that when you substitute x as 1 or x as 3 in the given polynomial, we get the answer to be equal to 0. Now I want you all to observe something very carefully. I want you all to take the sum of these zeros that we have got. As I've told you, x equals to 1 and x equals to 3, these are the zeros of the given polynomial. So now we are going to calculate few, we are going to do certain calculations over here. So I would want you all to calculate the zeros of the polynomial. So here in this case, when I take the sum of the zeros of the given polynomial, it is 1 plus 3, and that is equal to 4. So the sum of zeros in this case is equal to 4. Now consider the polynomial, and if you observe, what would be the coefficient of x in this case? So 8 is the coefficient of x in this case. So what I have done is, I have taken the ratio of coefficient of x and x square and I have multiplied it with minus sign. Why we are doing this, you will understand it. So I would be writing minus sign. Coefficient of x is 8 and coefficient of x square is 2. So here, I'm so sorry students, here if you see, the sign for 8 over here is not plus, it is minus, and since it is minus, that is why our middle term is minus 6x and minus 2x. So here when you substitute x ka value as 1, you're going to get 0. When you substitute x ka value as 3, you're going to get value as 0. So now when I put the value for coefficient of x as minus 8 over here, so already there is a minus sign and now we are putting it as minus 8. So minus into minus becomes plus, and when you reduce this, we get the answer to be equal to 4. Now similarly, there is one more thing. We are going to see what would be the product of the zeros. So let us calculate the product of the zeros. Product of the zeros is 3 into 1, which is equal to 3, because 1 and 3 are the zeros. If you take their product, it comes out to be equal to 3. Now let us take the ratio of the constant term and the coefficient of x square. So the constant term in this case is 6 and the coefficient of x square is 2. So constant term 6 upon coefficient of x square is 2, and when you reduce this, you get it equal to 3. Now I want you all to observe and conclude by yourself, what are you understanding. So here, when you compare these two terms and when you compare these two terms with each other, we get that the sum of the zeros, that is when you add the zeros of a polynomial, the sum of the zeros comes out to be equal to this quantity. And what is this quantity? You take the ratio, or you take the fraction of coefficient of x and x square, you multiply it with a minus sign, right? And similarly, the product of zeros comes out to be equal to the quotient of constant term upon the quotient of constant term and coefficient of x square. So here if you see, if the right hand sides of these two equations are equal, it means that the left hand sides are equal to each other, and hence we can say that your sum of 0 is equal to minus coefficient of x upon coefficient of x square, and your product of 0 would be equal to constant term upon coefficient of x square, right? So now, after observing this, we come finally to a conclusion. And what is the conclusion that we get? We get that let's say in general. Now what do you mean by in general? This was specifically for this polynomial, right, for this quadratic polynomial. But now let us define the relation for any quadratic polynomial which is of the form ax square plus bx plus c. This is the general notation for a quadratic polynomial. So they are saying that if alpha and beta, these are just denotions, okay, or notations that have been taken because we are generalizing the relation for every quadratic polynomial. So if alpha and beta are the zeros of the quadratic polynomial, px equals to ax square plus bx plus c, where your a is not equal to 0 because this is a quadratic polynomial, then as per the observations that we have made, sum of zeros would be equal to minus coefficient of x upon coefficient of x square. Right, now your sum of zeros over here are very important. I want you all to note this in your notebook. Sum of zeros in this case is alpha plus beta, and coefficient of x in this case is, if you see, coefficient of x is b, so minus b upon coefficient of a. So the general formula for the sum of zeros, or you could say the general form for relation between the roots and the zeros and the coefficients of a polynomial, of a quadratic polynomial, is alpha plus beta equals to minus b by a. And similarly, when you try to take the product of the zeros, so alpha into beta, where alpha and beta are two zeros of the given quadratic polynomial, when you try to take their product, it comes out to be equal to constant term upon coefficient of x square. Now what is the constant term? It would always be c, and coefficient of x square in this case is a. So here if you see, on one side we have the zeros of the polynomial, and on other side of the equation we have the coefficients of the polynomial, and that is why we would say that there is some kind of relation that has been established between the zeros of the polynomial and the coefficients of the quadratic polynomial. So these two equations are very important in this chapter, and you all should know them, that when you try to take the sum of the zeros, it comes out to be equal to minus b by a, where these are fixed, okay, like this is the coefficient of x, where a is the coefficient of x square, and when you try to take the product of the zeros, it comes out to be equal to c by a, where c is the constant term and a is the coefficient of x square. So you need to remember them like a formula. Alpha plus beta equals to minus b by a, and alpha into beta equals to c by a. And this is how we come up with the relationship between zeros of a quadratic polynomial and its coefficients. Now that we have seen the relation for a quadratic polynomial, let us just in short see the same thing for a cubic polynomial. Now, where quadratic polynomial was a polynomial whose highest degree of variable was 2, in cubic polynomial, as the name suggests, the highest degree of the variable here would be 3. So for a cubic polynomial, ax cube plus bx square plus cx plus d, where your a was not equal to 0, otherwise that wouldn't be a cubic polynomial. Agar a 0 ban gaya, then this term would completely vanish, and then your cubic polynomial will become a quadratic polynomial. So for a cubic polynomial, let's say if alpha, beta and gamma are zeros. Now you need to understand that the number of zeros depend upon the highest power of the polynomial. If the highest power of a polynomial is 2, it means that there are 2 zeros. If the highest polynomial or highest power of a variable in a polynomial is 3, it means that that polynomial would be having how many zeros? 3 zeros. So in this case, since the highest power of the variable is 3, hence we would be having 3 zeros, and we have taken the 3 zeros in general to be alpha, beta, and the third one is gamma. Okay, now if these are the zeros and this is the polynomial, so just like these relations, what would be the relation between these zeros and the coefficients? So when you try to take the sum of all the three zeros, that is alpha, beta and gamma ka addition is equal to minus b by a, that is minus coefficient of x square upon coefficient of x cube. Okay, you need to understand this, the denominator will always be the coefficient for the highest power of the variable. Okay, so for sum you would be having minus b by a. For product, this is alpha into beta into gamma, that would be equal to minus d by a. So just like over here we had the constant term upon the coefficient of x square, over here we would be having constant term upon coefficient of x cube, because this is denominator and it would have the coefficient for the highest power of the variable. Then finally this is a combination where at a time you are taking product of two roots and two zeros and you are adding them. So alpha into beta plus beta into gamma plus alpha into gamma. At a time you are taking combination of two roots. Like that you have taken all three possible combinations of zeros. You have added them and that would be equal to minus c by a. So this is the relationship between the zeros of a polynomial and the coefficients of a polynomial. But now here in this case we are talking about a cubic polynomial. So students, with this we come to the end of today's class, and to sum up today's class, we started with the zeros of a polynomial. We saw what exactly are the zeros of a polynomial. Then we moved on to establishing a relation between the zeros and coefficient of a polynomial, where we observed a few things and we concluded these two relations. Then we moved on to calculating the same for a cubic polynomial. So our agenda for today of knowing what are zeros of polynomial is completed, and we did see the relationship between zeros and coefficients of a quadratic polynomial as well as a cubic polynomial. I hope you all have enjoyed today's class and see you in the next video. Thank you.